All right, so let's talk about different ways where we can evaluate polynomials. So there are, might think there's only one way, you just plug it in, but there are actually three really convenient ways in their own rights for how to evaluate a polynomial. And so let's get into it. So here's our first example. So first example, f of x is equal to 2x cubed plus 3x squared plus 7x plus 4. They want us to find f of 2, which in other words just means this is a rule, this is a function, and it tells us to cube the function, double it, and then square the function, triple it, multiply the function by 7 and add 4, and then add all of those things together. That's the rule. It wants to know specifically if we put in 2 as the input, what would happen? What would the output be? So the first and probably most well-known way to do this is direct substitution. Literally all we're going to do is we're going to say f of 2 is equal to what would happen if we plug 2 in wherever we see the x's. So we'll do 2 times 2 cubed plus 3 times 2 squared. I'm just following the rule up here, by the way. Not, sorry. So 3 times 2 squared plus 7 times 2 plus 4. Okay, so and then all we do here is just simplify this. So this would be 2 times 2 cubed is 8 plus 3 times 2 squared is 4 plus 7 times 2 is 14 plus 4. So this would be 16 plus 12 plus 14 plus 4. And that's, let's see, 28, 42, 46. Okay, so 46. So if we just plug 2 straight in, we get 46, which is great. That seems pretty convenient. But I'm going to show you two ways that I think are actually either A, quicker, or B, easier than this. Okay, so the next one I want to show you, the next method is called synthetic substitution. I'm not going to go into why this works, which would probably be another video worth watching. But what we're going to do is we're going to take, so the function was 2x cubed plus 3x squared plus 7x plus 4. What we're going to do is we're going to take the coefficients, so the 2, the 3, the 7, and the 4, and we're going to take the 2 that we're interested in. So 2 is the value that we're plugging into the function. So what we'll do is most people put like a little box over there, and they drop their 2 in it, and then they take their coefficients, so 2x cubed, 3x squared, 7x, and then 4. And then watch this. What you can do is you can bring this down. So you bring that first number down, and what we're going to do is we're going to take whatever number comes down here, we're going to multiply it by this number up here. So we're going to take 2 times 2, and we're going to put the result right here. So 2 times 2 is 4. And then what we do is we multiply up and then add down. So all we're going to do is we're going to add 3 and 4 down. So we add down and then we multiply up. So we'll take 2 times 7, which is 14. So we'll multiply up and then we will add down. So 7 plus 14 is 21. And then we will multiply up. So 2 times 21 is 42. And then we will add down. So 4 plus 42 is 46. And look at that. You get the exact same answer as your direct substitution, but you don't have to like cube things and square things and add them all together. If you can just do some simple addition and multiplication, that will work. Another method I want to show you is called graphing. So I actually filmed this on my computer, so I'm going to switch over and let you watch it on the computer. If you have a TI 83 or 84 or a TI Inspire, or if you have a graphing calculator, go ahead and get it out, because I'll show you how you can figure this out with a graphing calculator. All right, so I want to show you how to evaluate a polynomial by graphing. And so what we're going to do is I've got the TI 84 here on my computer actually. And I'm going to show you how to do this step by step. So hopefully you have like a TI 83 or a TI 84, even if you have a TI Inspire or another graphing calculator, hopefully you can follow along here. So what we're going to do is we're going to key the function in. So I want you to go up and hit the y equals here in the top left corner. Your calculator looks slightly different from mine, but that's okay. What we're going to do is we're going to key in the function here. So this first function that we did here was 2x cubed. So we'll do 2x, x is up here. And then cubed, the way you do cubed is you raise it to a power, and then you want the third power. Now be careful here. If you start typing after this, you're going to stay up in the exponent. So you want to hit that right arrow, and it'll drop you back down. All right, plus 3x squared. You can either raise it to the second power like this, raise it to the second power, or there's actually a square button right there. I kind of like the square button. Plus 7x, and then plus 4. Okay, so we'll graph this. And when you graph it, it's going to look something like this. And this is a little hard to see, and we're supposed to evaluate when the x value is 2. I think if the graph doesn't even appear when the x value is 2 here, which it doesn't, I don't even think your calculator will calculate it for you. So let's go ahead and change our window a little bit. Let's see where we're at right now. So right now we have an x minimum of -10 and an x max of 10. And then our x scale is 1. And so what that means here is that this here is -10 for x, and this is +10 for x. And then this is -10 for y, and this is +10 for y. What we want to do is, we're fine as far as x goes, right? I don't really need x to go out to 10 or -10, so I'm just going to leave that alone. But it would be helpful if we took this maximum y value that we were possibly able to see and just raised it up quite a bit. So let's go to maybe, so let's scroll down here and set our y minimum to maybe, I don't know, -250, and then +250, and let's set our y scale to 50. That means for each tick mark, it's going to go up 50. Okay, so from here to here is 50. Okay, so, and this is really nice. So this lets us kind of see the features of this cubic function. Remember, cubic functions are the ones that kind of go up, and then sometimes they come back down and go back up. Sometimes they just go up and then get a little less steep and then go up again. But basically what we're going to do here is we're going to ask the calculator when x is 2, so right here, what's the output? What's the y value? Which looks like, if this is 50, it looks like it's just a little under 50, which would make sense because theoretically we should get 46 based off of what we did for direct and synthetic substitution. So the way you do this is you're going to go to second, and then you're going to use this calculate function. Imagine that a calculator has a calculate function. So you might hear me say hit second trace or second calc. Same thing, because you're actually going to hit the trace button after you hit second. And you got some options here. You can do value, you can do 0, you can do minimum, maximum, intersect. Those are all good. dy dx, that's a calculus function. And look at this. Oh, they have an integral function. That's awesome. Basically, we want the value function. We're just asking it, hey, if I put in a value for x, what is the y value that corresponds to it? If you wanted to find where the function crosses the x-axis, so where the y value is 0, you would use this guy. If you had a minimum, like if you had a parabola, you wanted to find the lowest point, you would use minimum. So anyway, I'm not going to explain all these to you because they're not all relevant right now. But 1 is the y value, so we'll just hit enter there. And by the way, if you're in that window, so if you hit second calculate, if you ever want to get to these, you can just hit the number and it'll just take you right to them. So if you just hit 1, it'll take you to value. What we're going to do is the computer's asking us, all right, what value of x do you want to check? And we'll say, I would like to know the y value that goes with 2 for x. And you hit enter, and what it'll do is it'll return the y value. Look at that. It's 46. So, which is exactly what we were hoping for. All right, so that's the third and final method that I want to show you for how to evaluate a polynomial. Let's look at a few more examples. All right, so we're going to look at a couple more examples here. So the next one here, our second example, is we got this function, 2x cubed minus 3x squared minus 4. And the question is, or I guess the directions, rather, say find f of 3. So we are just going to plug 3 in wherever we see the x's here. Okay, so f of 3 is simply 2 times 3 cubed minus 3 times 3 squared minus 4. So that's going to be 2 times 3 cubed is 27 minus 3 times 3 squared is 9 minus 4. So that's going to be 2 times 27 is 54 minus 3 times 9 is 27 minus 4. So 54 minus 27 is 27 minus 4 is 23. Okay, so when you plug in 3 as an input, you will get 23 as an output. Let's do synthetic substitution. So synthetic substitution. All right. So as a reminder, the function was 2x cubed minus 3x squared minus 4. Okay. So you might remember from a minute ago, we did the coefficients here. We wrote those all down, and then we threw our 3 up in the corner. 3 was what we were interested in evaluating the function for. Now, something that's really important, and I hope, the fact that you're still watching this gives me hope, because if you stopped watching the last one, then you're going to make some very bad mistakes. The coefficients here, you have to write them in descending order, and you have to include every single variable with its exponents. Okay, so we have 2x cubed minus 3x squared. Notice how there's no x here? We have to include that. Okay, so we've got 2x cubed minus 3x squareds plus 0 x's minus 4. You have to include that 0, especially not especially, for the exact reason that if you're missing one of these variables, you have to put it in there. Okay? All right, so what we'll do is we will bring this 2 down. We're going to do the exact same thing we did on the last example. So you start by bringing this down, and then we're going to multiply up. So 2 times 3 is 6, and then we're going to add down. So we will add these two numbers. So negative 3 plus 6 is 3. We will multiply up, so we'll take 3 times 3 and put that here. That would be 9. 0 plus 9 is 9. 3 times 9 is 27. And then negative 4 plus 27 is 23. Look at that. That's the exact same answer as we just got. Okay, all right, so that's the synthetic substitution. And we will go ahead and go over to the graphing now. Okay, so we're going to look at our second example here for graphing, and that's let's go over to the y equals, and we're going to go ahead and clear this function out. Actually, another side tip for you, if you'd like to use this function later, but you don't want to delete it because you have to retype it, what you can do is you can come over to the equal sign and just hit enter, and you can turn that function off, which is really nice in case you need to come back to it later. All right, so our new function is 2x cubed minus 3x squared minus 3x squared minus 4. Oh, shoot. And see, I did that. I forgot to move the mouse over, so it typed the entire thing up there. All right, so 2x cubed, make sure you hit this right arrow key. Minus 3x squared minus 4. All right, minus 3x squared minus 4. All right, so let's graph this. And our goal here is to plug in 3 for x. So the window already is pretty good for this. So let's go to second calculate. We'll hit enter here. We're going to do a value. We want to know when x is 3. And look at that. We get 23. Exactly what we were hoping for. All right, so last example here. We've got f of x is equal to 2x to the 4th plus 3x squared plus 5. And they want us to find f of negative 2. So the first method we'll use is direct substitution. And we're just going to plug in negative 2 wherever we see an x. So f of negative 2 would be 2 times x, which is negative 2, to the 4th power, plus 3 times negative 2 to the 2nd power, plus 5. So that's going to be 2 times, all right, if you have negative 2 multiplied by itself 4 times, that would be this scenario. And I'm going to say that this would give us 4, and then negative 8, and then positive 16. So if we do that, we'll get positive 16. Okay, so 2 times 16 plus 3 times negative 2 squared would give us positive 4 plus 5. So that's going to be 32 plus 12 plus 5. So that's going to be 49. So direct substitution tells us that our result is going to be 49. How about synthetic substitution? Synthetic substitution. Okay, so by way of reminder, our function was 2x to the fourth plus 3x squared plus 5. And so our coefficients in this case are, we've got a 2, a 3, and a 5. We are particularly interested in negative 2, right? I'm getting old. I have bad memory. Okay. I'm 29. I'm not that old. All right. So we're going to write our coefficients down. So we have 2x to the fourth. How many x cubes do we have? So we don't have any x cubes, so we're going to put a 0 there. It's really important that you put the 0 there. If you don't put it there, it's going to mess everything up. How many x squareds do we have? Okay, so this is our x to the fourth part. This is our x cubed. How many x squareds do we have? We have 3 x squareds. We have no x's. And then I just put a little, pound symbol here for our number. Sorry, hashtag for your generation. So that's going to be a 5. We're not going to write it in white. We're going to write it in blue. Okay, so what we've got now is we can bring this 2 down. And we will multiply up. So negative 2 times positive 2 would give us negative 4. Then we would add down. So 0 plus negative 4 gives us negative 4. We'll take negative 2 times negative 4. That gives us positive 8. We will take 3 plus 8 and add it down. We'll get 11. Then we'll do negative 2 times 11 and put the result right here. That would give us negative 22. We'll take these two numbers and add it and put the result right down here. That gives us negative 22. Negative 2 times negative 22, so that'll give us 44. And then if you take 5 and 44 and add them, look at that. We get 49. The exact same answer that we got from direct substitution. All right, so that's the synthetic version there. And we'll take it over to the graphing. So we'll do our last example of graphing here. Let's go to y equals. And I'm just going to clear out these functions. All right, let's see. We have 2x to the fourth, so 2x to the fourth power. I'm going to hit that right arrow key so I come down. Plus 3x squared, plus 3x squared, plus 5. And we'll graph this, see what we get. And all right. Oh, yeah, that's right. We have a quartic function here instead of a cubic. So sometimes they look like a U. There might be a little bit of a bend to make kind of a W here. I can't really tell. I'm not super worried about it because I only care about when x is negative 2. So I'm going to want to know what this value is right here. So we'll go to second calculate, and we'll do value. And I want negative 2. Be really careful here. This is the minus key, not the negative key. This is the negative key right there, okay? So negative 2. If you press minus 2, the calculator is going to be like, I don't understand what you're asking me to do. And you're like, hey, calculator, quit being so dumb. But it won't. All right, and then 49 is exactly what we got for direct and synthetic substitution. So awesome.